In this video, I'm going to show you slightly more advanced techniques for labeling sliders using inequalities, restricting domains, and even piecewise functions. Let's start with a nice way to label points using the function notation itself. Here I'm going to start with just a value like a equals 5. And next I'm going to plot this as a and f of a. You see, it will add this slider left and right and allow me to drag that point along the line. Now I can add a label and it will automatically label that with the point. As soon as I type something in, it's going to remove that. Let's just call this point. You see now it just says the word point and it's not very fancy. What if I wanted to still show that point? I could do equals a comma f of a. The problem is it's not using those values. So what I'll oftentimes do then is use backticks, which enables a math mode and it will make things look a little nicer. It still is not giving me the inputs. Well, there's one last thing that I need to do. I'm going to zoom in and show you. $ and braces around variables is how we can show our inputs. But if I do the $ and the braces around the f of a, it's not quite going to work. So sometimes we'll have to do a little bit of extra work to make that end up coming through. I can define a new variable as b, place that in here, and now I don't need quite so much. It's still, it takes some coding here, but that will show me both words and that active label that will adjust as I go. Now there's different situations when you might need to combine words and math type. You can call upon any variables that you've defined in here using that type of input, and you might see that along the way in the work that I share with you. The next thing that we might want to do is maybe plot regions for this function. I don't need any of these inputs. Now let's say, for example, I want to show the regions where the function is below 0. You might have, for example, a polynomial inequality that would involve solving something like this. I think these kind of problems are great to be able to visualize. Here you can see the small range where it's above 0 and the range where it's below 0, multiple different zones there. We can also attach something to the end of this function to restrict the domain. So let's say I only want to graph it where this thing is increasing. Well, unfortunately, I have some kind of oddball max and min values. Let's go with something a little simpler. Looking at this graph, we've got it increasing from -infinity to 1. I could limit it to that domain from -infinity to 1, which is x is less than or equal to 1, and only plot that left side of it. This is just adding a restriction to the domain. We won't be able to make the same restriction on the range, and that's because it's the output of the function, and just the way that Desmos works isn't quite designed to do that. We could, if we made a slight change and made that y, then I think it would work. Let's try it less than or equal to -1. Yeah, so getting rid of the function notation allows us a little bit more usefulness with that restriction. There's a great example of using piecewise functions in Desmos here where they separately graph each of those. But there's also a way that we can create a single defined function that is piecewise as well. Here I'm going to create a function that just has multiple constants. For values of x that are to the left of -1, I'm going to graph a constant at 0. For values from -1 to 1, I will graph a constant of 2. And then for values greater than 1, I'll plot 4. Now notice how I didn't actually put the inequality for the last segment because it will actually just plot the last segment as everywhere else. And we'll notice that if I actually leave a gap anywhere, like here, instead of going from -1 to -1, let's go to 0, it will even fill in that gap as well. So you do have to be kind of careful as you define these. I think I prefer to be very explicit, like here to say for x greater than or equal to 1, I want to plot that 4. And it will jump if I drag. You'll even get it sometimes to show undefined at certain points. I'm not really getting that to happen here, but if I were in theory to click on the ends of one of those lines where it's not a strict equality, or it is a strict equality, then it would be undefined right at the end of that segment. But these can be really helpful, to plot and evaluate those points for piecewise functions.